Good morning, friends. So, uh, we are going to start the part 2 of 2Z interview questions. So, let's go one by one. The first question today I have for you is what are the functions of Sdcch and Sdcch? So, Sdcch, we are having many functions. Let me list it out for you. Location updates, SMS, ciphering initiation, equipment validation, subscriber authentication, and call setup signaling. So these are the six functions of Sdcch. So let's go for Sdcch, or the slow associated control channel functions. One is timing advanced data, transmit power control, transmission of signaling data, radio link supervision measurements. So these are the Sdcch functions. Third question today I have for you is what are the reasons of handovers? So it's a very interesting one. What are the reasons of handovers? Due to what triggers us to hand over to another cell, or to make an handover. So what is signal strength or the RX level which may initiate due to degradation in RX level, we may initiate a handover. That's a reason for the handover. Then we are having signal quality, RX quality, we are having power budget, we are having timing advance, or we are having interference. So these are the 5 reasons to handover. Then the fourth question for today is what are the shortcomings of handover? What may be a shortcoming of the handovers? So one may be call drop, a ping pong handover, or a far away cell effect. So these are the 3 shortcomings of handovers. Then the next question I'm having for you is what are the advantages of frequency hopping? You're having frequency hopping in GSM or the 2G. So what are the advantages? So one is frequency diversity, we're having interference averaging, we're having enhanced capacity also. So these are the 3 advantages of frequency hopping. What are the frequency hopping, how frequency hopping is help in enhancing the network capacity? So that's very important and a very root question. So frequency hopping implementation will enable more aggressive frequency reuse. Due to hopping, we can aggressively reuse the frequencies. Due to more aggressive frequency reuse patterns, that leads to better spectrum efficiency. So it can add more transceiver in the existing sites, while maintaining the network quality, good network quality. And there is another point also, frequency hopping, compressing the available spectrum to make room for extra capacity also. So that's how it enhances the network capacity. Then the next question for you I'm having is a very important one. What are the frequency hopping parameters? Which is very important, and mostly it will cover your planning fundamentals also. So like, what are the parameters used in frequency hopping? One is mobile allocation, one is hopping sequence number, the HSM. The third one is mobile allocation index offset, or otherwise called as MIO. We are having hopping indicator, or FHI. So I'll discuss basically on these 4 parameters. These are very important. One is mobile allocation, or MA list. So what is MA? MA is a set of frequencies the mobile is allocated to hop over, the range of frequency to hop over. Maximum of 63 frequency can be defined in a MA list, or the mobile allocation list. The next one is hopping sequence number, HSN, which is very important, which determines the hopping order, like in which order the frequency hopping happens in the cell. It is possible to assign 64 different hopping sequence numbers. Yes, if you are setting hopping sequence 0, it will provide you cyclic hopping sequence, and if you are providing hopping sequence number from 1 to 63, total 64, that will provide you various pseudo random hopping sequences. So So it depends on you what kind of HSM you are using, 0 or 1 or till 63. The next one is mobile allocation index offset, MIO, which is again important. Determines inside the hopping sequence which frequency the mobile starts transmitting on, the initial frequency. So the value of MIO ranges between 0 to n minus 1, where n is like the number of frequencies defined in the MA list. In a mobile allocation list, let's say 15 frequencies are defined, so n is 15 here. So the MIO would be 0 to n minus 1, means 0 to 14. N is 15 here, so 15 minus 1 is 14. So 0 to 14 will be the MIO range, mobile allocation index offset range. Then the last one is FHI, or the hopping sequence, sometimes referred as hopping sequence, which defines a hopping system made up by a associated set of frequencies, MA, to hop over and sequence of hopping HSM. The value of FHI varies between 0 to 3. It is possible to implement, or define all 4 FHI, the frequency indicators, in a cell. This parameter is actually basically specific to some vendors. Okay, so that's all about the parameters, important parameters in frequency hopping we use in 2Z. So that's all for today. So tomorrow we'll come with some more questions and some exciting answers. Thank you so much. Keep liking, sharing, and subscribing to the channel, and please do comment and let us know if we can improve this video with adding some more or extra details. We are continuously trying to give you the latest update with all the technologies and questions or answers or any kind of discussion, any important topic. Thank you so much. Keep watching. Bye bye. Take care.